Hello everybody, Earth.Otherwise here to continue our journey through game programming in C++ start to finish by Eric Yazwa. Chapter 8 is about managing where items are in your scene and determining if they are in the view area. Essentially, we want to determine if something is in the view area, then determine if that thing is also visible, meaning there's nothing between it and the camera. If we do this, we can essentially determine whether or not we want to even pass the vertices that make up an object onto the shaders, or even if we want to do anything with them at all. We'll do this with frustum culling, occlusion culling, and a very simple scene graph. Frustum culling is creating a collision box using your view space and checking to see what is in it. The key here is to remove everything you can until and unless removing it is more costly than drawing it. Occlusion culling is checking to see if something is completely covered by another thing that is closer to the camera. If it is, we don't draw the further object. Finally, a scene graph is a simple list of items or spaces with other items or spaces inside of it, which, if you can't see the larger item, then you can't see the smaller item. Think of it as an opaque cube inside of a transparent cube. If we test and we can't see the transparent cube, then there's no point even considering the opaque cube in our tests. Now, in order for us to properly use these techniques, we are going to need something to draw and something to not draw. Our current method of creating cubes one at a time out of sprites is far too slow, if we want even a reasonable number of cubes. So obviously we're going to have to create a cube class, which is what has been sitting on the screen this entire time. We'll need to access multisprite.h in our cube class, and actually this should be $pragma once. And we're going to need to access, or rather include, we're going to need multisprite.h. We are also going to need vector. And finally, we are going to need glm. So include glm/glm.hpp. This cube is going to have some private variables. It's going to need a glm vec3 position, or m position. It's also going to need a float size, or m side length. And it is going to need a vector of strings, a std vector of std string of m textures, so that we can put a texture on each cube face. Now it's also going to have a pair of getters, one for its position, so it will be glm vec3 is what it will return, and it will get position, and it's just going to return m position. And we're also going to have another getter, which is collision radius. The collision radius in this, and all instances where we're dealing with cubes, is half the side length multiplied by the square root of 3, or, to make things far, far simpler, just use the side length. So float get collision radius and return m side length. Did I No, I didn't misspell anything. So there we have it, our two getters. So, obviously returning side length isn't the actual thing. It's not half the side length multiplied by root 3. But that is only, this side length is about 2/10 larger than it needs to be. So it's a very small difference. And doing square roots and division and stuff is a little bit slower than literally just using the number that you passed in. We're going to need a constructor that takes a glm vec3 position a float side length, and it's going to take 6 strings. std string, going to take 6 of these, and they will be called first, second, third, fourth, fifth, and sixth texture. Perhaps texture file path? Yeah, texture file path. So, that's 1, 2, 3, 4, 5, 6. And let's just cut these in half. And then we're just going to have first, and then second, third, fourth, fifth, sixth. Finally, we'll need a void returning function called add cube to multi-sprite. And this isn't going to take anything. Actually, it will have to take something. It will have to take a multi-sprite pointer called multi-sprite. That way, it can actually... yes, we got to make sure we put everything here in otherwise. Namespace, otherwise. Obviously, yours is called something different. But yes, so that it can use multi-sprite without a without anything else. So, gonna just create the definitions. So I'm using IntelliSense to do so. You'll probably have to pop into the .cpp file and do it manually. Get rid of this. Add things to our namespace. And now, we do a little dance and make a little love using an initialization list for this. We will set our M position equal to position, and we'll set our M side length equal to side length. God damn it. There we are. So, now we do the work of pushing back each of the textures to our vector. And as you can see here, I actually made a small mistake. There's texture and then first texture. I was wondering why my numbers didn't add up, so I'm just going to remove that. You guys probably did it correctly, so you don't have to worry about it. Anyways, getting back to what we were doing, we're going to need to go M textures. Is it M textures? Yeah, M textures dot pushback, and then I'm just going to copy texture file path here and paste it in here, and that's 1, and then copy and paste it 6 times and add first, second, third, fourth, fifth, and sixth. So now down here in add cube to multi-sprite, we are going to first create a new float called half side length, and it's going to be equal to M side length divided by 2. We could just pass that in, but I didn't feel like it. And now we're going to go into our main, scroll on down to our first cube, and we're going to copy all of this. In fact, I'm going to cut it right out of there and paste it right in here underneath this. So, we actually need our load PNG. So, number include image load.h. There we are. But instead of this, we're obviously going to have M textures and then we're going to have 0, 1, 2, 3, 4, 5. With that done, we need to change this from multisprite2 dot to multisprite arrow for each and every one of them. Most of the rest of this will stay the same for now, and we'll actually probably change it later, but obviously the XYZ will become the XYZ of the position. But it will be the position either minus or plus half length there, so that our position is at the very center. So let me show you. Every 0 will be M position dot X or Y or Z, depending on it is, minus half side length. That is for every 0 in the X. Every 0 in the Y is M position dot Y minus half side length, and every Z is M position dot Z minus half side length. So that's every 0 in the X, every 0 in the Y, and every 0 in the Z. So down here at the bottom, which is actually the top, so every 1 in the X position, actually let me just copy this. So this is minus, 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 and then this is plus, plus, plus. So instead of minus there, we just have plus half side length, plus half side length, and plus half side length. And we just do that for every single one of them. Now, before we go back to main, I'd like to note that this is probably the most inefficient way that we could be doing this. In reality, we only need 8 vertices for a cube, but we're still using a rendering function that was created for 2D. We'll likely have to create a multi-sprite, but for the 3D realm at some point. For now, try not to create more than, say, 10 cubes at a time. I tried to create like 1,000, and it literally overflowed my RAM. Like, I was up to like 2.5 gigabytes of RAM when it overflowed, trying to create a couple thousand of these. So, yeah. Just create 10 or fewer. And if your computer can't even have 10, you're gonna have to figure out a way to do 3D multi-sprite immediately, rather than later when the rest of us have to do it. But hey, it's a good lesson. So, we're going back to main. So here we need to just go ahead and get rid of the second cube, and instead we need to make our new cubes. So we're going to include our new cube class, num include ocube for me dot h. Yours should be whatever letter your engine is, and then cube, just in case we use another cube function, like another library that has a cube function. And then down here, after multisprite.2 is in it, we're going to go ahead and create a for loop. And I'm going to go for int float is equal to, I'm going to say -20. Float I is equal to -20, so long as I is less than 20. I plus equals 2, so it will go up by 2 every time. Get rid of this. There we are. So that will do it 10 times for -20 and then -18, etc., and it will do it 10 times. Shouldn't do it 20 times. So now we're going to create a cube, but in order to do that, we need someplace to store 10 cubes. So a std vector of ocubes called cubes. So otherwise ocube. Now we're going to do cubes.pushback, and then in here we're going to go otherwise o cube And then we're going to add a GLM vec3. And in here, the vec3 will be, the x will actually be I. And then the y, let's make the y, I don't know, 0.5. And then the z can be -2. And that should be it for the GLM, and then I used capital L's instead of colons. There we are. So that's the first part of an O cube, and then we need a float side length, which is going to be 1.0f, and then we need our strings. So I deleted them here, but I'm going to get back our old strings. Our old strings, and then finally close the O cube, and then we close the pushback. And there we are. We have created, we've created 10 cubes. But when we create them, I'd also like to cubes.back. I'd like to add cube to multisprite and add and give it multisprite 2. That way, a reference to multisprite 2. That way, we're drawing them as well as adding them. So let's build and run everything. It may take a long time to build because, as I say, we are doing this very, very inefficiently. But once we do get it running, we should just be able to see a couple cubes in a line, and we won't be able to see a couple of them because they will be off screen. And there we have it. After an absolutely atrocious amount of loading, we have our 5 cubes on screen and presumably 5 cubes off screen. So next time we'll look at making that load time a little bit shorter by not drawing the things that we can't see. This has been Earth Otherwise. Thank you for watching.